Okay, this is number 18 in your book, and it says to use partial fractions to find the inverse Laplace transform of this function. Okay, so we want to find our f of t. So we're given this function, right? This is our rational function, and we're going to use partial fractions, right? Notice we have four factors of s minus 4. So I'm going to go ahead and rewrite this guy, right, as so s cubed over s minus 4 to the fourth power is equal to, and I'm going to break it up into four factors. So 1, 2, 3, and 4. And I'm going to use so we have rule 1 and rule 2 on page 289. And I'm going to use rule 1 because I have, this is linear factor partial fractions because we have linear factors. So in other words, s minus 4 is the linear factor, right? The highest power is 1. So we have, the way we rewrite this sum is we start with s minus 4 in this case, and then you just go up. So s minus 4 squared, then we have s minus 4 cubed, and s minus 4 to the fourth. If you wanted to go in descending order, you could. I just want to be consistent with the book. So the goal is to find our coefficients, so you can call them A1 through A4, or we've just been using A, right? We can say B, C, and D. So we want to determine these coefficients. So let's do some partial fraction. This is a nice little review. So I'm going to go ahead and multiply both sides of my equation by s minus 4. So let's see. Let's write that down. So multiply left-hand side and right-hand side of this equation by s minus 4 to the fourth. So when we do that to, right, this guy above, we obtain the following. So we get s cubed, and then we get, let's see, a times, one guy is going to be left, so s minus 4 cubed plus b s minus 4 squared plus c s minus 4 plus, and then d. Okay, so let's determine A, B, C, and D. So the first thing that we want to do, or we want to try, is if s is equal to 4, right, can we maybe find a coefficient? Well, if s is equal to 4, right, in our equation above, I get 4 cubed, right? This guy's 4. I'm inputting 4 here. So I get 4 cubed, which is 64. And notice, right, this is going to be 0 because I have 4 minus 4. This is going to be 0, and then this is going to be 0. So I'm just left with D. So I have, this is nice, 64 is equal to D. So we already found one coefficient. Okay, so if we try to find so we need A, B, and C. And if we try to, well, we already input 4, so that's not going to give us anything new. So to find A, B, and C, we're going to differentiate this guy right here. So if we differentiate, we get the following. So we get 3s squared plus, and then, whoops, not plus, that's equals. And then I'm going to bring down, right, power rule. So I'm going to use 3a times s minus 4 squared plus, right, derivative of this guy is 2b s minus 4 plus, let's see, c, and then that's just 0. Okay, now if s is 4, right, this is a completely different function. So we have, well, this is nice. 4 squared, right? 16 times 3 is 48. And then if I input 4 again, all this is 0, this is 0, and then C is 48. So hopefully not too bad, right? Just, again, some algebra, evaluating some expressions. So now let's take the derivative again. So the second derivative, right, of this guy would be 6s equals, this is just a constant, so this is nice, 3a s minus 4. Again, I'm just using the power rule. 2b, and that's pretty much it. And so again, if s is 4 in this case, I get 24 on the left, and then again, this guy's gone. So I am left with 2b, and then that obviously implies b is equal to 12. Okay, so we have B, C, and D. So now we can definitely find A, right? We have a nice equation that we can use. And I mean, here we can let S be 4 again, which is fine. I'm going to let it be 0 just because 0 is nice. You can use 1, you can use 105, but 0 is so nice. So I'm going to use 0. So if I input 0, I get, well, 0 cubed is 0. Let's see, we're left with negative 4 cubed plus b negative 4 squared plus, oh, negative 4 plus d, right? So I just let s be 0 in here. And this is just algebra, right? This is negative 64a plus 16b minus 4 C plus D, but remember we know what A is. Well, no, we don't, just kidding. We don't know what A is, but we do know what B is. It's 12, and C is 48, and D is 64. So doing all the math, right, multiplying, adding, these actually end up canceling out. It's actually 192 minus 192. And then when we solve for A, it's 1. So again, I'm just using some algebra. Okay, so let's go ahead and put back our A, B, C, and D back into our, whoops, our, oh, okay, let me try this again. Okay, there we go, into that guy, right, specifically the right-hand side. So we have, well, let's go ahead and let me write it right below. So I have f of s, right, this is a function of s, and it's equal to, okay, s minus 4. So what is my a? My a is 1. Okay, plus s minus 4 squared, and my b is 12, plus s minus 4 cubed, and my b, or my c is 48, plus s minus 4 to the 4th, that's a 4, and my D is 64. Okay, so again, what's the goal of the problem? Well, it was to find the inverse Laplace transform. So we want to find our function of t. Okay, so we are going to just get a different color here. So if I apply let me just write it out. It actually looks nicer. So the Laplace inverse, right, of this guy, and again, let's see, to save some room here. So the Laplace inverse, I mean, this really should go over here, but hopefully you guys can see that. So by using the property of linearity, okay, I know this guy is going to be, well, it's supposed to be f of t, right, by definition. So I'm going to do this piece by piece. So I get, okay, so 1 over s minus 4 plus the Laplace inverse of 12 over s minus 4 plus the Laplace inverse of 12, just kidding, 48 over s minus 4. Oh, my hand's hurting. I gotta stretch it out. Let's see, plus, that is a, yes, that is a 3. Plus the Laplace inverse of, okay, it should be yellow, but I think you guys know what I mean. Okay, there we go. Now, let's find the Laplace inverse, right? Equals, okay, the Laplace, or the inverse Laplace of 1 over s minus 4, right? Way back from table, what's 4.1. on page 271. So if we look at our table, 1 over s minus 4 is e to the at, and my a here is 4. So I definitely know, whoops, oh, just kidding. Oh, let me not, I don't want to move that. 1 e to the at. Sorry, it's been a long day. It's Monday. E to the at. Okay, so at. Okay, so that's this guy. Check. Okay, what about this guy? So 12 over s minus 4. And I'm actually missing a, oh, it really is Monday. There is a 2 right there, right? Because my multiplicity is 4. Okay, so I want to find the inverse Laplace, and I'm actually going to go ahead and take out my constant. I think it's going to make things easier. It's up to you. I encourage you to do it, especially on your test, because you will receive partial credit if you make a mistake. Okay, so all I'm doing is, again, for my property of linearity, I'm allowed to take out the constant. So, okay, that's really yellow. Laplace inverse of 1 over s minus 4 cubed, and of course I write really, really big. So plus 64, I'm taking out the 64, Laplace inverse of 1 over s minus 4 to the 4th. Okay, let's see if I can do this in one line. Okay, so this guy is the same. So e to the 4t, right? We already found the inverse Laplace of that. Okay, so plus 12 times what? Now, this guy, right? Again, I'm looking at page 290 in your book. Second column, right? I'm looking at my f of s. So let me go ahead and just write it maybe up here so you guys can refer to it. So I'm looking at n factorial over s minus a all to the n plus 1, right, where s is strictly greater than a, right? This is my f of s, and notice there's an f of t right next to it. It's e to the at times t to the n. Okay, so I have, this is my s minus a, okay, so this is my 4, and then I have n plus 1. Okay, my n plus 1 is that 2, right? That's really my, well, so n is 1 in this case. N is 1, right, because that's really, right, 1 plus 1. Well, if n is 1, then this guy should really be 1 factorial, which it is, right? There's a 1 there. So so I can find my f of t. That's definitely e to the 4t times t to the n, and, well, n is just 1. Okay, so what about this guy? So plus 48 times, okay, same thing. Here, a is 4, and my n, here, my n is 2, right? Because this is really 2 plus 1, right, which I get 3. But if that's 2 plus 1, right, my n is 2, so I should really have 2 factorial above. So what we're going to do is, let me just get a different color here. I'm going to multiply by 2 factorial, but I can't, change this value. So if I multiply by 2 factorial, which I'm really multiplying by 6, I'm going to really divide by 2 factorial, right? We're allowed to do that because I haven't changed the value. So with that said, right now this guy looks exactly like this guy. Okay, so then we can say we have e to the, let's see, 4t times t to the n, and t to the n is, and actually let me be careful, I have my 2 factorial here, right? This guy is t to the t squared. Okay, and I have 30 seconds left for the video, or it's going to time me out. So similarly, we're going to do the same thing here. We're going to, right, multiply. This is really going to be 3 factorial, and then we're going to divide by 3 factorial. And then we're going to end up with 64 over 3 factorial times, and then e to the 4t times t cubed. And okay, so all you're going to do is reduce, reduce, and then that's your f of t.